Hello and welcome to my undergraduate research presentation. My advisor, Dr. Nancy L. Green, and myself call this project the Automatic Detection of Rhetorical Devices in Scientific Policy Articles. So what does that mean? Well, let's just jump right into it and we'll talk about it. So if you've ever read a scientific policy article, you may notice that the author is trying to persuade you in a certain way, trying to get you to think in one way or another. Well, to be unbiased, the reader has to say, well, how are they trying to do that? How are they trying to make me think one way or another? Because it's not just magic. So how do they do it? It's typically through the use of rhetorical devices. And we wanted a way to algorithmically determine where these rhetorical devices were in the article, because if you have to do it by hand, it's very slow and cumbersome to find them. So, using an ocean acidification article by Johnson and White, we went through and hand-annotated three different types of rhetorical devices that we wanted to research, these being parison, antithesis, and anti-metaboly. In addition to all this, we also created a helpful graphical user interface for the user so they could see where these were highlighted. Okay, so what are these devices? So parison is known as the corresponding structure in a series of clauses. For instance, he that is to be saved will be saved, and he that is predestined to be damned will be damned. To be saved will be saved, to be damned will be damned. The same parts of speech on both sides, and it's very common, so it's a parison example. Next we have antithesis, which is the rhetorical contrast of ideas by means of parallel arrangements of words, clauses, or sentences. For example, promise her anything but give her arpage. So promise her anything, give her arpage, two contrasting ideas to make one global picture. Okay? Lastly, we have anti-metaboly, which is the reverse lexical repetition. For instance, ask not what your country can do for you, ask what you can do for your country. Your country, you, your country. Reversed on one side, so it's an anti-metaboly example. In addition to all these, we also allow the user to search for specific words and find statistics such as the average sentence length and the number of words in the text. So we're not going to go over the algorithms themselves, we're just going to go into the results. So we ran all of our algorithms on the Johnson and White article, and we wanted to compare how they worked and what they returned as a result compared to our hand annotations. So we wrote two parison algorithms, and we'll just go to those right now. Figure 3 is the old algorithm. Figure 4 is the new algorithm. So we notice that Figure 4 closely matches what we hand annotated. That was something that we immediately noticed. However, it's not always the case that it returns a correct result. So, of the southern, off the coast, and then we also have for the new one, in the, of the, off the. So that's not a very good parison example, but for most cases, if we combine the results, then it's most likely going to return something very close to what we hand annotated. Okay? So for antithesis, on the other hand, we found a couple results that were returned. So for instance, increasing influxes of CO2 cause a decrease in pH, which results in an increase of H+, and thus a decrease in hydroxide and carbonate ions in most surface waters. So it's an overall, you have increasing, decreasing, which will be positive polarity, negative polarity, which is just positive tone, negative tone, overall to make a neutral tone, thus being a high probability of being an antithesis example. Okay? And we also lastly wanted to see how the anti-metaboly algorithm would work. Well, in practice, it works okay. But when we're testing on a real article, it seems to not work so great because, as you can see, these are just conjunction words. The, are. So that's not a very good example, unfortunately. But we still wanted to see what it would possibly return. Okay? So, in summary, what we found was that with both parison algorithms, we can combine those to see results that were very close to what we wanted, which was very good. There were some false positives, of course, but in future work we're going to try and improve our pattern detection, syntactic patterns specifically, and then removing false positives. That was the big problem with both of our algorithms. But if we can remove those, it gets very, very close to the real thing. There's also progress to be made with our antithesis algorithms. So we could further improve our we could reduce our false positives. We could write our own algorithm to determine polarity, use a different dictionary for antonyms, etc. So we plan to not only improve those, but then include other rhetorical devices, because readers need to have a clear understanding of how authors attempt to persuade them, so they can determine the legitimacy of the arguments. This concludes my undergraduate research, and thank you.